Welcome to Choosing from the Many Ways to Docker in Azure. Today we're going to take a look at Dockerizing an application and then hosting it in the cloud in lots of different ways. Now what's really cool is Azure has lots of different methodologies for hosting containers in Azure. So the magic question is, well, which one should I use? And hopefully we can answer that today. Here's the part where I tell you I am definitely going to post the slides on my site tonight. Have you heard that? Has it worked out? Yeah, that really bugs me too, which is why I have already posted these slides at robrich.org. Let's head over to robrich.org. Here's Choosing from the Many Ways to Docker in Azure, and the slides are online right now. Achievements unlocked! Woo! While we're here on robrich.org, we can see some of the things that I've done recently. Microsoft has given me some awards, Docker has as well. AZ GiveCamp is really fun. AZ GiveCamp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver completed software to charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like to attend a GiveCamp here in Bangalore, then find me here at the event or hit me up on the socials up here in the top corner. And let's get a GiveCamp in your neighborhood too. Some of the other things that I've done, I do a whole lot with Docker and Kubernetes. So I actually got the Tip of the Captain's Hat award from Docker last year. That was cool. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woo! So there's my claim to fame, my coveted .NET Rocks mug. And if you'd like it, no, I'm just kidding. Richard Campbell's awesome. Okay. So let's choose from the many ways to Docker in Azure. We talked about this guy. Docker in Azure. We have AKS, we have ACS, we have ACI, we now have ACA, we have HCR. Which of these things should we use for hosting our web app? Well, I would argue that's kind of not the right question, but rather, in what use case do each of these make sense? Do I have that use case? In which case, that's the right solution for me. So let's take a look at each of these and figure out what we need to do. Taking a step back, what is Docker? As an industry, I think we've almost moved past this, but Docker is about containers, about kernel virtualization. So what is kernel virtualization? Well, we're virtualizing the operating system, where previously we virtualized the hardware. So now instead of configuring the SCSI bus, we configure how much of the CPU we want. That's cool. So Docker didn't invent containers. Containers and C groups and namespaces and jails, all of those existed previously. Docker just made it really easy for us to use them. So it's a suite of command line tools. Here's VMs on the left and containers on the right. We can see that on the left, we only got 3 VMs into place. Now, this diagram definitely isn't to scale, but we also got 7 containers on the same hardware because we're using them more efficiently. Here on the left, we needed a copy of our operating system in each virtual machine, and in containers, we don't. So that's really cool. Containers. Now, one of the benefits but drawbacks of virtualizing the operating system is that the host operating system and the guest operating system have to be the same. So if we're hosting a Linux container, we need to do it on a Linux OS. And if we're hosting a Windows container, we need to do it on a Windows Server OS. What's missing? Well, what about GNOME and KDE? What about Red Hat and Ubuntu? Can I host a Red Hat container on an Ubuntu host? Yeah, because what are we virtualizing? We're virtualizing the kernel, the Linux kernel. What's the kernel inside of Red Hat? Well, it's Linux. What's the kernel inside Ubuntu? It's also Linux. What else is missing? Well, what about Mac? Now I went to the Docker website and I downloaded Docker Desktop for Mac. Are you telling me that's not how this works? And what about Windows Desktop? Yeah, this only talks about Windows Server. Yes, in Windows Desktop and in Mac, we have to do something a little bit differently. So in production, we definitely want to do it like we do here on the right. But in development, we'll probably want to do it here on the left. So I have my server. In this case, it's my laptop. I'll install my host OS. Maybe this is Mac OS or Windows. I'll install my hypervisor. In the case of Windows, it's Hyper-V. In the case of Mac, it's HyperKit. And then I'll install a guest OS. Let's make this Linux. And then I'll install the Docker engine inside of Linux. And then I'll be able to run my Linux containers. And that's how we can do Linux containers on non-Linux operating systems. We'll do this virtually. And since we have a hypervisor, we could run other VMs as well. In production, we definitely want to do it this way. We want to run as efficiently as possible, as close to the hardware as possible, because we get a whole lot more containers. But in development, yeah, we can still cheat and do this. The cool part is, if we're running Windows 10 or Windows 11, this layer right here can be WSL. So we just turn on WSL, then we install Docker Desktop, and it goes, hey, I've already got a Linux here. Can I use it? Yes. And now we've got the Docker engine running inside of WSL. Cool. So let's talk about orchestrators. Now the interesting thing about orchestrators is there are many to choose from. An orchestrator will run containers on a set of machines. So we give it some instructions. We say something like, run 3 copies of my web server, run it across availability zones, make sure it never goes down. I'm not talking about which server should I run the application on. I'm just giving it these instructions and telling it to make it so. And that's what an orchestrator is. An orchestration engine probably does a little bit more. We get visualization into how these containers are running. It might automatically restart them if they die. And we have a couple other benefits, monitoring and load balancing, perhaps auto-scaling. That can be characteristics of an orchestrator. So an orchestration engine, it basically keeps our containers healthy. It's going to watch those containers and make sure that the containers continue to run. If, for example, one of the machines that my container is running on goes down, it'll automatically restart my container somewhere else. And when I wake up in the morning, it'll tell me all the things that it fixed. That's perfect. I don't need to worry about it. So as we start looking at orchestration engines, we could pick from many. There's Kubernetes, Mesos, or DCOS, Docker Swarm, Azure Service Fabric, Amazon Fargate. All of these are orchestration engines. All of them have different opinions about how it should monitor and scale and restart containers. But at the end of the day, what we're doing is picking an orchestration engine that will keep track of our containers and make sure they run as expected. So as we start looking at running our containers, let's first talk about how we might build our containers. So here's a diagram that I built that kind of nicely walks through that process. We start out with a Docker file. And this Docker file is the configuration as code that tells us how we build up our container. We'll have various lines that explain the instructions to the machine of how to be able to build up this reusable thing. So we'll take our Docker file and we'll build it into an image, this binary blob. Now the cool part about this image is that it already contains all of the compiled pieces, all the configuration, everything is set just so. Then we'll start our image as a container on a Docker runtime. Now maybe that's Kubernetes, maybe it's something else, Amazon Fargate. We could look at various orchestrators that we choose to run there. We plug in Ethernet, we plug in power, and up pops our image as a container. Cool. Docker file, built as an image, run as a container. We can also choose to do that with a Docker Compose file or Kubernetes YAML file to target multiple Docker files or multiple Docker images that we might choose to pull and push from Docker Hub. Now what's interesting about Docker Hub, unlike, say, GitHub, is that we're pushing and pulling binary blobs. If I download an image from Docker Hub, I don't need to recompile it. That's really cool. I don't want to recompile an image when I just download it. So we can take that Docker Compose file, we can build or pull many images, and we can start them together as a suite, in this case on Docker Swarm, but just as easily on Kubernetes or another orchestrator. Cool. So let's build an application and containerize it. I have here an empty folder, and I want to build up a website. Now we could build lots of websites, but in this case, I'm just going to say .NET new MVC, name is site, output is dot. Now both name and output are optional. If I didn't pass in a name, it would use my folder name, in this case demo. And if I didn't pass in an output folder, it would build a new folder inside this for my application. So I would have the demo folder, which would have a demo folder inside of it. And in this case, I wanted to take a little bit more control of that. Cool. Let's open this up in VS Code and start to poke at it. Oh, I still have the VS Code from the last thing. That was pretty cool. Okay, so we've got our application. Here's our controller, and our controller has an index method, and that references our home view, and it says welcome here at the top. Cool, we've got our application. So now let's containerize it. Well, the first thing we need to do as we containerize it is to build a Docker ignore file. New file, .docker ignore. Now this Docker ignore file is everything that we don't want in our production container. So I don't want bin and obj, those are both built. I don't want the packages folder. If I'm in a .NET Framework project, I don't want node modules. If I'm in a node project, I want those things to be built new in this project. I also don't want user-specific files, so the .vs folder, star.user. I also don't want temp files, so star.tmp, star.orig. And I also don't want non-production files. So we have app-settings.development, app-settings.development.json. And we also have one more here, this launch settings.json. So one difference between a Docker file and a gitignore file is that a gitignore file will look in every directory by default, and a Docker ignore file will only look at the root folder by default. So I need to specify, go look recursively in every folder to make sure that I don't have things that leak through. Cool, so that's everything that I don't want in my production container. Now let's take a look at everything that now let's build up that Docker file that is our configuration as code. Cool, so I'm going to create a new file. This one is Docker file. And this Docker file is that configuration as code that tells us how to get from our source code to our running container in production. Now there's four main verbs here in a Docker file: from, copy, run, and cmd. Now there are other verbs inside of a Docker file, but we'll get to see some of them today. But these are the four main ones. If you get how these four work, you can read and write most Docker files, which is really cool. Okay, so from, I want to stand on the shoulders of giants. I want a base image that includes all of the things that I need to be able to build this .NET app. So I'm going to head off to Docker Hub. I will search here for .NET, and I'll land here on this repository that is kind of a meta repository, a launch pad into all the other ones. So we have .NET samples, a lot of Docker files that show us how to build it, .NET Monitor that shows us how to be able to look at .NET. Runtime depth is everything we would need to install .NET, but .NET is not installed yet. Built on top of that is runtime that allows us to be able to run console applications, but not websites. Built on top of that is ASP.NET, which allows us to be able to run websites, but not build our application. And on top of that is SDK that allows us to be able to build a .NET app. So let's start there. I'll come grab this, And here's the image name right there. And scrolling down a little bit, we can see that there are various labels. Now, by default, 7.0 is built on Debian. Now, Debian is fine, but Alpine is smaller. So if I choose the Alpine variant, then I can get a much smaller base image. So let's do that. From this Alpine, cool. Now I have the build tools, and now I can be able to build my .NET app. So let's copy in all of the content from the folder on my host directory where I run the docker build command into the current directory in my image. Well, what is that current directory? Let's go set it. Work dir/src. Now I could specify this as anything. I could say var lib foo var, wherever I wanted it to be. But in this case, /src is completely sufficient. Cool, I've just copied everything into place. Now, what are the things that I might run on the console to be able to build this? Well, I would run .NET restore, .NET build. I'll build in release mode. .NET test. I want to run my test. I'll also do that in release mode, so I don't end up with one release build and one debug build. .NET publish. I'll build that in release mode, and I'll do that to the dist folder. Cool. Those are all the commands that I would run from the command line to be able to build this website. So I want to run them as Docker commands. So let's run this one, and we'll run this one, and this one. Cool. We now ran those as Docker commands. Now, our CMD, the thing that we'll use to start it, let's say .NET site.cll. Now, we do need to switch our work dir to /dist because that's what we built here. And we do need to set a few environment variables. So let's go grab these and set them here. That just says, hey, run ASP.NET in production, listen on port 80, expose port 80. And so now we've got our container ready to go. We could run this Docker file in production and it would do just fine. But we've broken some of the rules of thumb of Docker files. We have build tools in our production image. If someone was able to pop our container and start uploading malicious code, they could compile it and start it inside of our container. We don't want to do that. So let's split this in half. I'm going to come back over here to Docker Hub, and I'll pop open ASP.NET. And there's a similar one that doesn't have build tools, but will run my website. So let's come grab this one. And scrolling down, we can see that we've still got an Alpine variant of that. I'll use that. Excellent. Back here in VS Code, from there. Cool. Now we do need to copy our content, so let's change this to /app, and then let's copy our content from the dist folder to our current directory. But right now, it's going to look in our host machine for that content. And that isn't in the host machine, it's over here in this build stage. So let's copy from equals build, and now let's name this one as build. And so it will look to the build stage here, and it will look to the dist folder, and it will copy everything. Now our source code and our build tools are not in this second stage. So we have one stage, and let's name this one our build server image. It's not actually a server, it's an image, but we can think of it as the build server. And this one is our production runtime server image. GitHub Copilot noticed I typed that before. Cool. So now we have two stages in our Docker file, and we've better utilized that best practice. Now there's one more thing that can help us here. We can leverage Docker layers. .NET Restore is going to restore all of our libraries, and that might take some time. So if I'm building this locally and I just want to do some stuff quickly, and I come in here and I change a JavaScript file, it's going to re-restore those NuGet packages because it uncached this layer. really what I want to do is something like this. I want to .NET Restore first, then copy my files, then build, test, and publish. I still need my manifest, my list of packages, so let's copy in site.csproj into the current directory, and then .NET Restore, and then copy everything else, and then build, test, and deploy. Now if I only change a JavaScript file, I will uncache this layer, and my NuGet packages are still cached. Cool. We're able to use Docker caching to be able to make our subsequent builds faster if we chose to use cached packages. So here's our Docker file. Now we'll come to the command line and we'll say docker build. I'll tag this as Docker in Azure. And now we do a build process to get our website into this image. Now, internet permitting, this will go restore our NuGet packages, or I've already built this, and so I may crash out of this in a second. All packages are up to date. .NET build, looks like our build path. We don't have any tests, so we don't have any failing tests. So all of our tests passed. We published, we flipped over the other stage. Cool. Docker image list, and now we can see that we built this brand new Docker in Azure container. Okay. So let's run it. Docker run -p. I'll map 8080 on my local machine to port 80 in the container, and I'll run Docker in Azure. Cool. Now we've got that website running, so let's head over to localhost 8080, and we've got our website running. Cool. Now what's awesome is the balance of this talk will use this container that we just built. Well, kind of. It'll use the one that I built last night. Docker container list. So the next step would be to tag this with my registry name. So let's do that. Docker tag nope, not that one. Docker in Azure, and I'll name it my Azure Container Registry. Cool. So we've built our container, we've built our image rather, and we're now ready to be able to leverage that in the cloud doing lots of interesting things. So first off is Docker Container Registry. Now Docker Container Registry is where we can push our images. Why isn't it called an image registry? Because naming is hard. That's where we'll push our images so that we can be able to leverage them in interesting ways. Now we could push this to Docker Hub. That's definitely an option. Docker has public repositories for public things, which is excellent. They also have paid plans that allow us to be able to create private registries if we wanted to. But we could also flip to Azure Container Registry, a private Docker registry for our images that stays private in our subscription. So that's cool. Let's go to Azure. Make sure I'm still logged in. I am. Very nice. Let's create a new resource. I want to create a container registry. Yeah, JFrog is awesome. I will pick a container registry, and so now I will say, let's put this in the Kubernetes resource group. I will call this Rob Rich. I'll put it in US West 2, and I'll use a standard. Actually, I'll use a basic SKU. Oh, hey, Rob Rich is already in use. Why, yes. Because I've created this previously, so let's go to the one that I've created previously. And so we have this container registry where I've pushed this image into place just so that we had it available to be able to use and we didn't have to watch it upload. So here's my Docker in Azure container, my Docker in Azure image that we just built. Cool. So we've got everything in our container registry, And for the balance of this talk, we'll be able to use that image pushed to that registry to be able to launch our container in various places in Azure. Cool. Docker in Azure. What we're doing is picking our orchestrator. Do we want an orchestrator that gives us more control? Do we want an orchestrator that gives us more managed things so we don't have to worry about it? That's what we're picking here. We've seen this where we have our process to the cloud, where we choose to run everything. Or we upgrade to infrastructure as a service, where we outsource some things like hardware. We can upgrade then from that to platform as a service, where now we outsource a whole lot of the machine details. We no longer need to run Windows updates. Or we can upgrade to software as a service, where we just log into a website and do stuff. Now, the cool part is, as we pick an orchestrator, we can pick from various spots in this thing of things that we want to own versus things that we want to give away. Cool. So our choice is, what do we want to outsource? We'll take a look at lots of different container runtimes in Azure that allow us to be able to outsource different things. So the cool part is all of these are real Docker. We could create any OCI compliant image, whether we're using Docker or another tool. We can run it in any OCI compliant container runtime, of which all of these are. This isn't Microsoft Docker. This is actual Docker. So that image that we built with Docker tools will run just fine up on Azure. So for each of these items, we could say, is this the right one? But instead, let's take a look at the pros and cons of each one and understand when this is the right solution. What are the scenarios where this is the best fit? First, Azure Container Service. Now, the cool part about Azure Container Service is that you could pick from one of 3 templates, and it would automatically provision this with ARM templates to be able to launch this content in your subscription. So it makes it really easy to start, but you own it from now on. You need to patch the VMs, you need to be able to update your software, and so they retired it some time ago. If you're still on Azure Container Service, I'm impressed. The cool part, though, is you could pick from DCOS or Docker Swarm or Kubernetes. If you're on DCOS, you can move to Mesosphere's open source DCOS project. You can just spin up VMs and put it there. If you're using Docker Swarm, you can move to Docker Enterprise and do things there. And if you're on Kubernetes, now you can move to Azure Kubernetes Service, which is just built-in normal upstream Kubernetes. Next, let's take a look at Service Fabric. Now, I put an asterisk of legacy here because we don't see it a whole lot anymore, but it's still a big thing. This is a lot of how Azure runs Azure. They run it with Azure Service Fabric, so it's not going away anytime soon. If you like this abstraction, it is perfect. Now, I would argue that it's a little bit weird. The cool part is it's a fully managed container orchestrator, and it also runs web apps with platform as a service type of functionality as well. So we start out by creating a Service Fabric template inside of Visual Studio, because reasons. And then we go into the portal and we can upload that service into Service Fabric, and it will automatically scale our things. We don't need to worry about node pools or patching or anything. We just say how many instances we want, and it just does it. That's kind of cool. If we don't want to manage anything, this is a great solution. On the upside, we outsourced all of the cluster management, all of the patching, all of the scaling. All of that is owned by Service Fabric. And the only thing we need to own then is the process running in the container. That's cool. All of those other details are handled by Azure. I like this one if you have more of a Windows tint to you, or you're running legacy workloads, or if you just don't want to deal with any container orchestrator stuff. If Amazon Fargate looked really appealing, then Azure Service Fabric might be a good fit too. On the downside, though, that Visual Studio project configuration, that's kind of weird. I'm like, why doesn't this say like a JSON file or a YAML file? Why is it a whole separate project in Visual Studio? But nah. So when might I choose it? You can run both Windows and Linux on Service Fabric, but it started out as Windows. So if you have a Windows thing, it might feel a little bit more at home on Service Fabric than on Kubernetes. So you can definitely run Windows stuff on Kubernetes as well. Next, Azure Kubernetes Service, AKS. This is the big dog. This is cool. This is real live upstream Kubernetes. This is not Microsoft Kubernetes. This is real Kubernetes. The cool part is that the control plane is a fully managed control plane that we don't pay for. If you run Kubernetes on GCP or on AWS, you're going to pay for the control plane nodes. On Azure, you do not. That's kind of cool. I like that. I like not paying for stuff. So I just manage the VMs that host my actual work. That's cool. Let's go futz with Kubernetes. So I'm going to come back here into Azure, and I'm going to create a new resource, and I'm going to choose Kubernetes service, and I'll get to pick my options. Azure Kubernetes service. Yes, I would like to create one. And I'll choose that Kubernetes resource group that I just happen to name nicely that way. I'll choose dev test. Rob Rich in West US 2, that looks good. Availability zones, yeah, sure. AKS pricing tier, I'll go with standard. Ooh, free tier, that's pretty sweet. And Kubernetes version 1.26.3, I like that. And let's automatically upgrade it. I really love that. My node size, I can come in here and pick the size of Azure VM that I want to be for each node and pick the pricing associated with that. Well, I guess I'm picking both at the same time. And then how many nodes do I want? Well, in this case, yeah, one is good. I could choose to autoscale as well. Next, I'll choose the node pools. Right now I've got an agent pool. That's great. If I want additional node pools, I can do that. Virtual nodes is really excellent. We'll come back to Azure Container Instance and why that's magical. But this button is just, I've been asking for this button for a while. That is nice. Next, we can take a look at the authentication. Do we want to do local accounts with Kubernetes RBAC? Do we want to move that authentication into Azure instead, or Azure AD? Or do we want to just do Azure AD with Azure stuff? We can start poking at the networking and do other stuff, and there's a lot more options. But what we'll notice here is that I completely missed the part about how, hey, Rob Rich already exists because, well, yeah, I already built this cluster. So the cool part about this is that it is automatically patched to the latest version of Kubernetes. And so I can just use this in Kubernetes. Here in node pools, cluster configuration, you can just choose the version of Kubernetes that you want to grab. Now, in my case, I have it set to automatically update, and thus it's disabled. But if you've ever tried to upgrade Kubernetes and you know how painful that is, it is so nice to be able to just pick it from the drop-down and have it just do stuff. That's cool. So we've got Kubernetes ready to go here, and I've switched my context here to Kubernetes. So kubectl get all, and we can see that we've got nothing running inside Azure right now. I'm going to go grab the Kubernetes YAML files that I built. If I had another minute, I would live code them, but just pulling them in is really fun. This includes a deployment, so we'll go grab that image, a service that will get that in place, and an ingress that will launch it as well. So let's launch that inside of Kubernetes. kubectl apply-f k8s. And now my container running from Azure Kubernetes service is going to, our Azure container registry will automatically get pulled into my Azure Kubernetes service, and I'll have this app running. kubectl get all. Now it does take a minute for DNS to update, so it will show us that this is the public URL for that website, but it's going to take a while to get there. So we may choose to just port forward into that Kubernetes. So I'm going to port forward 8080 on my local machine to port 80 inside of Kubernetes, and that'll get around the DNS issue. And here is that website running in Azure on Kubernetes. Cool. That worked out well. Let's kill this one in kubectl delete -f kds. Let's kill that one off in Kubernetes and take a look at other orchestrators that we might choose. Cool. So when might we choose Azure Kubernetes Service? If we like Kubernetes, if we like open source, if we like that kind of model of being able to pull in various packages, then Azure Kubernetes Service could be perfect. Azure Kubernetes Service is definitely compatible with Dapper and Istio and the other packages that we might want to look at inside the Kubernetes ecosystem. So the cool part is we have that upstream open source. This isn't a forked version of it. And so we're able to do both Windows and Linux hosting of Kubernetes containers. On the upside, it is that native Kubernetes experience. On the downside, Kubernetes YAML. And so if you like that open source thing, then this might be a great fit. If you don't like the open source methodologies, if you don't use Kubernetes details, if you don't want to manage that YAML, then you might go back to Service Fabric, or let's continue on and take a look at Azure Container Instance. Azure Container Instance is an API for spinning up containers. As we're coding, what are the fundamental things that we look at? Well, we have variables, we have classes. If we were to build a cloud, what's the fundamental building blocks that we would look at? Well, we'd have VMs, we'd have containers. And so this is just a REST API over creating those containers. So the cool part is now we get excellent utility billing in kind of this fully managed mechanism. Now we don't have automatic restarts, we don't have automatic load scaling. It's just an API where we can say, hey, go launch that thing. So let's go create some Azure Container Instance stuff. Now let's start off by doing it from the command line. And this is a monster command. So I'm going to say, go create this container named this, in this resource group named this, give it this URL, or this image rather, go log into my container registry with these two environment variables that I carefully set earlier so that you don't see my secrets, and expose this port, and create it on this DNS name, and then go grab me that DNS name, pulling that back out, which is really cool. This will take a second to spin up in Azure Container Instance, but we could also come in through the portal and point at our container registry and pick our repository and our version. And we can come over here to the three dots and we can say run instance, which will basically do that same REST call. It'll spin up a single instance. If that single instance crashes, we need to go spin up another instance. Did it finish? It did. So let's head over to this URL. And here is our web app running in Azure Container Instance. Now what's cool is it's utility billing. So it is billed per CPU second. And so I'm not going to run it very long. I'll go kill this off. Actually, let's take a look at it first. AZ container list. I'm going to take a look at the images that I've got, or the containers that I've got running. That surprised me that it didn't include it. AZ container logs. Let's go look at the logs for this container, and we can see the console logs of it starting up. Or, yep, there it is. And now let's kill it off. AZ container delete. And we'll specify the name, and that will go delete this from the Azure Container Instance. Cool. So now that's a great API. If we want to do a multi-tenant instance, or if we want to build up a process, we can build this on top of Azure Container Instance. On the upside, we've outsourced all of that patching and hosting and runtime stuff, and we get to choose the process and the container health and restart. So we get to be the orchestrator that restarts our application. So when is this really helpful? Because it's utility billing, it's a really cool mechanism for being able to start things really quickly, try them out, without having to worry about starting it and hosting it in Kubernetes and YAML, and it's just a REST API. On the downside, it doesn't scale and it doesn't restart, so this isn't great for production hosting. But if I wanted to build a service where each client got a separate VM for their session, then I might use Azure Container Instance to build my platform on top of it. Or maybe I just want to quickly test this thing in development and I just want to fire it up and see if it goes. I could use Azure Container Instance for that without having to install Docker Desktop on my machine. Now there is a really cool thing, the virtual kubelet. We saw that checkbox inside of Kubernetes as we set it up. We can create a virtual node in our Kubernetes cluster that is Azure Container Instance. One big infinite node that can run everything. Now, some things don't make sense there, like a daemon set. We can't really run an agent to be able to look at all the things on that node because, well, it's a multi-tenant infinite node, and we don't own all of it. But for the most part, we can run anything in Azure Container Instance through this virtual kubelet. Now we don't have to worry about auto-scaling our Kubernetes nodes, and that can be really powerful. Next, Azure App Service. Now, traditionally, we think of Azure App Service as platform as a service, and it allows us to be able to run various web apps. But we can also deploy a single container here as well. And the cool part is it auto-restarts just like any other IIS app, and we can run both Windows and Linux here as well. So let's go do that. Let's go create a new web app. And we'll spin up that web app. And as we build this web app, let's pick that Kubernetes resource group, Docker in Azure. We can choose to upload code. We can make it completely static so it has no runtime. Or we can choose a Docker container. That's what I'll choose here. I'll choose Linux. And then it's not finding my region, not finding my app service plan, but that's okay. I can create a new one. And then I can point it at a single container, and I can point it at my Azure Container Registry, and I can pick my image from that registry, and I can choose a specific version, or I can choose latest, in which case it creates a webhook, and anytime I push to that, it restarts my Azure web app with that new instance. Cool. So once I've got that in place, I now have the normal web app details of auto scaling and auto restart, which is amazing. I could also come here into my, and for the sake of time, I won't actually create it, but I could also come here into my container registry and pick that image, and next to the spot of launching it in Azure Container Instance, we can also deploy it to web apps straight away as well. And it'll just auto provision all the things and answer all the questions for us. Cool. So Azure Web App, Azure App Service. Now this is cool because it's all managed everything. I don't need to worry about my orchestrator. I don't need to worry about my container restarts. It's running like any web app. That's cool. On the downside, I only get one container in this. So if I have multiple containers, lots of microservices, I have lots of web apps, which means I might be stretching my app service plan. So if I have lots of containers, I'm going to reach more towards AKS. If I have a monolith in a container, I'm going to reach more towards Azure Web App. Cool. So we've chosen to outsource pretty much everything. We're just running our container process. And so it's great if we have a monolith inside of a container. So when might I choose that? If I'm modernizing a monolith. I've got this monolith on a VM, and I want to put it in a container. I put it in a container, I run it on Azure App Service, and away it goes. Next up, we could talk about Azure Container Apps. Now, Azure Container Apps is really cool. It's a brand new service and thus no slides on it, where it kind of abstracts away a lot of the details of Kubernetes. It is running on Kubernetes under the hood, but we don't have access to any of those Kubernetes details. It's a simplified YAML experience where we would just specify the container, the image name that we want to run, the number of instances, the ports, and it just launches it. It takes care of the service and the ingress, and all of those parts are just kind of managed for us. We could also specify Dapper details of being able to connect to other services. So it's a great way to kind of get your feet wet with Kubernetes without all the sprawl of Kubernetes YAML. But it being managed Kubernetes that kind of abstracted away from us, we can't really run those more intense Azure-y things, Kubernetes-y things that we want to run. So Istio is out of reach. Dapper is built in, which is nice. But some of those other pieces that we might choose to run on Kubernetes are not available in Azure Container Apps. So Azure Container Apps is great if we don't want to manage all those Kubernetes details. But if we do want to manage those, then we would choose AKS instead of Azure Container Apps. Another option for installing, for using Docker inside of Azure is just to provision a bunch of VMs and install stuff on it. So we might choose to install Kubernetes there. We might choose to install Docker Enterprise there. We could choose to install anything. It's now our resources, and we completely manage all the things. Now, why would I want to do this? Why wouldn't I just let Azure kind of do that piece? Well, I have outsourced buying the hardware, but I'm choosing to manage pretty much everything else. If I have a managed service that crosses across boundaries between clouds, and I want to ensure that the exact same version of Kubernetes runs on all of the clouds, it may be more effective for me to just get a bunch of VMs, pull them together into an internal network, and install my version of Kubernetes there, rather than relying on AKS or something like that to do it for me. So yes, I must do it all, but it gives me that platform stability because I did it all. So yeah, I would do this if I'm creating a cross-cloud service, but other than that, managing Kubernetes is hard, and I would really rather outsource that to others. So we looked at a lot of different ways of running Docker in Azure. Let's now start to categorize them so we can predict when might we choose this as the best option. Comparing these from the most managed, where Azure is doing the majority of things, to the least managed, where we're owning most of the things, we can see that Azure App Service is kind of the most managed. Then Service Fabric, arguably they're equal. Azure Container Instance is kind of in the middle. And AKS gets more towards we manage it. And then VMs is the where we manage everything. Azure is really not helping us more than just getting us hardware. Similarly, we can look at this as how many containers do I have? If I have many containers, then I might choose to build a platform on top of Azure Container Instance and take that orchestration role for myself. Or I could install Kubernetes or another orchestrator on a bunch of VMs, and now I can control lots of pods. AKS is great for also running lots of pods, not to say that it's less than ACI or VMs, but I'm getting more into the managed territory. Service Fabric can also run as many things as I want because it's an infinitely scalable pool. As I get more towards dev test use of Azure Container Instance, I'm only running one container. And finally, Azure App Service, where I'm only running a single container as well. Now, that might be perfect. If I have monolith and I want to launch it inside of Kubernetes, then Azure App Service might be perfect. If I want to quickly spin up a test and see if that works in the cloud, then Azure Container Instance might be great. If I get to more of a microservices platform, then I'll start crawling up this diagram, and AKS may make more sense, or Azure Container Apps. So kind of putting all of this in a grid, and this is the money shot of comparing all these things, we can see that they all work on all platforms, that certain pricing models apply to each one, and which ones allow me to auto-scale, and which ones do I own that auto-scaling. Azure Container Instance is the only one that doesn't automatically restart, and from what I understand, they have recently built that, so maybe it does now. And the only one where I own the VMs and need to patch them is, well, just getting VMs. Cool. So the take-home message here is that Azure has lots of different mechanisms for being able to run containers. Now, should I learn all of them? Which one should I choose? I would still argue that's not quite the right question. Instead, we ought to ask the question, where am I? What are my needs? And Azure will meet you there. Azure has lots of options for hosting containers, more or less managed, more or less containers, more or less utility billing or management control. And so you can pick that spot where you're the most comfortable, and you can host that inside of Azure with real live Docker containers. This has been a lot of fun getting to show you the many ways to host Docker in Azure. The slides are online right now at robrich.org. Thanks for coming.